Okay, so this is the 2023 Higher Level Applied Maths Leaving Cert paper, question 1. So in part A here we have a directed graph. It's represented by the adjacency matrix M, where M is equal to this matrix here. Okay, so we have to use the nodes below to draw a graph represented by M. Okay, so let's run through that. So let's see, at the beginning here we have A and A here, and we see a 1 here. That means there must be a loop at A, so I'm going to draw a loop here and an arrow here. Now when we go from A to B here, we see there's a number 2 here. That means there are 2 edges going to B from A, so I'm going to draw 1 here, and an arrow in that direction. Okay, next one then, we've got A to C, there's nothing. A to D, there's 1. So we're going to draw an edge from A to D in that direction. Next thing, we've got A to E, nothing. A to F, nothing. B to A, nothing. B to B, nothing. And B to C, we've got 1. So you've got to draw one edge here and an arrow in that direction. So that's B to C. We've got nothing here, and then B to F we've got 1. So you've got to go over here to F, and that's in that direction. Okay, so let's look at C then. We've got C to A, there's 1. So you've got to draw an edge up here and an arrow. That's C to A. C to B, there's 1. So we've got another one coming back here to B. So that's C to B. We've got C to C, there's 1. So there must be a loop here at C. That's C to C. And then we've got C to D, there's 1. C to D. And then we've got C to E, there are 2. C to E, there are 2. So from C to E we've got 1 here and another one like this. That's C to E. And then C to F, nothing. D then, nothing along here until we get to F. So D to F, there's 1. So I'm going to come up along here. Actually, I'll go around the edge here, I think. So that's D to F. Now E to A, nothing, 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 nothing along here until we get to E. So from E to E there are 2 loops at E. So we're going to draw 2 loops here. 1, 2. So that's E to E, and then nothing from E to F. F to A, nothing. F to B, 1. So F to B, we've got 1, so you've got to come back this way to B. And that's it. And that's it for part A1. Okay, so part 2, write down a cycle which starts at node B. So remember, a closed walk in which all the intermediate nodes are different is called a cycle. So let's see, if we start at B, we can go B to C and back to B again. So that would be 1. So we can go B, C, B. We can go B, C, A, B. So you can do B, C, A, B. We can do, let's see, B, C, D, and we can't go to A because the arrow is in the wrong direction. So B, C, D, we can go to F and B. So we can go B, C, D, F, and back to B again. So there's 3 different cycles which start at node B. Okay, so let's look at the next one then. I've written this one out. Let's see, how does a directed graph differ from an undirected graph? Well, what I've said here is an undirected graph. Undirected graphs have edges that do not have direction or arrows. In other words, each edge can be traveled in both directions. Directed graphs, on the other hand, then have edges with arrows so that they can only be traveled in one direction. So in the graph above, for example, you can travel from C to D but not D to C. So when you come up along here, you can travel from C to D, but you can't travel from D to C. So that's my difference there between undirected and directed graphs. Okay, next question then. In part B, a particle moving along a straight line has velocity v is equal to ds dt, which is 2t to the power minus t, and t is positive. Use integration by parts or otherwise derive an expression for s of t, the displacement of the particle at any time t, given that s of 0 is equal to 0. Okay, so it's suggesting here that we use integration by parts, so it's probably best to do that. So integration by parts is in your tables, it's just the integral of u dv is equal to uv minus the integral of v du. We want to integrate this expression here, 2t e to the power minus t. So let's do that. We've got, we've got ds dt is equal to 2t e to the power minus t. We want to integrate with respect to t, so let's just bring that dt over 2t e to the power minus t dt, integrate both sides. Here we're going to get s, or s of t if you like, is equal to. So we're going to integrate the right hand side here by parts. Now how are we going to do this? Now you've got to remember the inlate rule here, which is inlate. So we have inverses, logs, algebra, trig, and exponential. So we want, let's see, in our expression here on the right hand side, we have 2t here, which is algebra, and then we have e here, which is an exponential, e to the power of something. So it's in the right order already, so that's fine. So what we're going to do then is let u equal to 2t, and then let dv equal to e to the power minus t. So differentiate the u, here you get du dt is equal to 2, or du is equal to 2 dt. On the right hand side here, this part here, what we can do is just integrate both sides. So if I integrate this here, I'll get v, and if I integrate e to the power minus t, so I want to integrate e to the power minus t. So that will give me e to the power minus t anyway, but because there's a minus here, I'm going to have to put a minus here, because if you differentiate this, you'll get minus e to the power minus t times minus 1. And the minus 1 and this minus here will cancel to give us the plus up here. So that's it. We have our u, we have our du, we have our v as well, so that's fine. So let's just substitute everything in here. Here I've just integrated both sides. So let's see. We have u times v. So u is 2t, so we've got 2t. We've got to multiply that by v. V is minus e to the power minus t, minus e to the power minus t. Then you've got minus the integral of v, so it's minus the integral of minus e to the power minus t, and du. Du is 2 dt. So that's our integration by parts formula, if you like, this part up here. Okay, so let's just simplify all of this here. So we've got minus here, so that's minus 2t e to the power minus t. Here we've got minus and a minus here, so that's going to be plus. And there's a 2 here as well. I'm going to bring that outside the integral symbol as well. So we've got the integral of e to the power of minus t dt. Okay, so let's just do the integral then. We've got minus 2t e to the power minus t plus twice the integral of e to the power minus t. We've done that already up here. E to the power minus t up here is just minus e to the power minus t. So it's minus e to the power minus t. And that's it. And because this is an indefinite integral, we've got to add our constant of integration as well. Okay, so let's just simplify this a little bit. 2t e to the power minus t minus times plus here is minus 2 e to the power minus t plus c. So the next thing we've got to do here is work out what C is. And if we go back to the original question here, it tells us here at the end that S of 0 rather is 0. So S of 0, we've got S of t. This is S of t here. So we've got S of 0 we know is going to be equal to 0. So that's going to be equal to minus twice 0 e to the power of minus 0 minus twice e to the power of minus 0 plus c. So here we've got 0 is equal to, well, this here all just becomes 0. And over here we've got minus 2 e to the power of 0. This is just 1. So 1 times minus 2 is just minus 2 plus c. Bring the minus 2 over to the other side and you get a c is equal to 2. So our final answer then, we were asked to use integration by parts or otherwise to derive an expression for S of t, the displacement of the particle at any time t, given that S of 0 is equal to 0. So all we've got to do is write this down here with our 2 here. So it's going to be, our answer then, if you like, is S of t is going to be equal to minus 2t e to the power of minus t minus 2 e to the power of minus t plus 2. And that's it for part 1. In part 2, we've got to work out S of 3. So we want to work out S of 3. So in other words, we just got to put 3 in here. So it's going to be, let's see, minus 2, 3 e to the power of minus 3 minus 2 e to the power of minus 3 plus 2. So let's work through that. Let's see, we've got minus 6 e to the power of minus 3 minus 2 e to the power of minus 3 plus 2. So that will give me, let's see, minus 8 here. This is minus 8 e to the power of minus 3. So it's 2 plus, no, sorry, it's 2 minus 8 e to the power of minus 3. And that's really your answer. It doesn't say to give your answer to any number of decimal places, so maybe this is what they're accepting as the answer. But if you were to do that on your calculator, you'll get, let's see, 1.601703453 and so on. It's going to go on forever. But I suspect this is what they want as your answer here. And that's it for this question.